Dear student, today we're going to learn about relationship in mathematics. So usually relationship with two set involve the element of two set. Let's take for example set A, which consists of element A, B, C, D, and set B, which consists of element W, X, Y, Z. The first set is, we call it the domain, and the second set is the codomain. We can use the arrow diagram to indicate the relationship between the relation between set A and set B. Take for example this one, set A is related to W in set B, and set A is also related to X in set B, and we can use the arrow to indicate that, and B is related to X, and C is related to Y. So this A, B, C, we call them as the object, and W, X, Y are the images. And the set of images in this case, W, X, Y is the range. Let's look at the example. We have set A and set B involved in relation, and the domain here is all the element in set A. So this is 2, 3, and 4, and the codomain is all the element in set B. So it is 4, 9, 16, 20. Whereas the range is all the element that in set B that involve in the relation. So we only have 4, 9, 16. 20 is not involved in the relation, so it is not the range. So we have only the range as the elements are 9, 4, 9, and 16. The image of 3 is 9, and the object of 16 is the image, the object is 4 in set A. There are three ways to represent a relation. For example, if we have set A and set B, the element in set B is 3 times of the element of set A. One way to represent the relations is by the arrow diagram. So we have set A and set B. So this is the relation is 3 times of. So we have element 1, 2, and 3 in set A, and the element 3, 6, 9 in set B. So the relation is 3 is 3 times of 1, 6 is 3 times of 2, and 9 is 3 times of 3. And the second way is by way of graph, where we use the X and Y axis, where X axis is represented by A and Y axis by B. So in set A we have 1, 2, 3, and in set B we have 3, 6, 9. So we put a dot at the intersection point between 1 and 3, because that's a relationship between 1 and 3, 2 and 6, and 3 and 9. The third way to represent a relation is by order pair. In order pair, we can put the relation in Z, where 1 and 3 is in this one of the order pair, 2 and 6 another one, and 3, 9 another one. Now let's look at this example. We have 4 order pair here to indicate the relation between the object and the image. Right, so let's see what are the domain. The domain here is the first member of the order pair, which is 5, 5, 6, 7. But in a domain, we do not repeat 5. 5, we only have 6, 5, 6, and 7 as a domain. And the codomain is 10, 12, 15, and 18. So this is the codomain, all the element in set B. So 10, 12, 15, and 18. So the range here seems it is the same as the codomain, 10, 12, 15, 18 as well. And image 5, there are 2 images for 5. One is 10 and the other one is 12. So the image for 5 is 10 and 12. And the object for 15, not 5, is object for 15 is 6. You can see here, this is another type of arrow diagram where set x is mapped into set y by the relationship 2 to from 2 to -5 and 6 to 1 and 3. So you are asked to find the range. So the range is actually all the images in set y. So we have the range are by -5, 1, and 3. And if you put this deletion in order pair, it will be 2, -5, 1 pair, 6, 1, and 6, 3. There are 4 types of deletion. The first type you can see from the diagram, the arrow diagram here. Each and every object in A have only one image in B. So this is what you call a 1-to-1 relation. We look at the second type. There are 2 objects in A that having one image in B. This type of relation we call many-to-one relation. So in the third type, we can see that there is one object in A that have 2 images in B. We call it one-to-many relation. The fourth type of relation is many-to-many. As you can see, each object have many images, and these many objects have the same image in D. So this is many-to-many. So now let's learn about the concept of function. A function is a special deletion whereby two conditions must be fulfilled. The first condition is the relation type must be either 1 to 1, yeah, must be either 1 to 1 or many to 1, and right, and all the object must have an image. Now let's look at the first type of relation to see whether it can classify as a function. So we can see here this is 1 to 1, right? So first condition is fulfilled, and the second condition is all object must have an image. So you can see here all the object has an image, so it fulfill the second condition. So 1 to 1 relation, this 1 to 1 relation is considered a function. So now we look at the second one. In the second one, the first condition is 1 to 1 or many to 1. So you can see here this is many to 1. So the first condition is fulfilled, and the second condition is all object must have an image. You see here all the object has an image, so the second condition is also fulfilled. So we can say this deletion is a function. So the third type is, let's look at the first condition, whether it is 1 to 1 or many to 1. You can look at here, this is actually is 1 to many, right? So this object has two images, so it doesn't fulfill the first condition, even though it fulfills the second condition, whereby all the object has an image. Yeah, so this is not a function because it doesn't fulfill the two conditions. So this one we have many to many. So for this relationship, it is not 1 to 1 or many to 1. This is many to many. Naturally, this is not. It doesn't fulfill the first condition, and the second condition is fulfill that all has an image. There's no problem. But then it has to fulfill two conditions, so it is not a function. Another possible scenario is that you can see in this example, this is a 1 to 1 relation. So if we want to see whether this relation can be considered a function, so the first condition 1 to 1 is fulfilled, but the second condition, it doesn't fulfill the second condition because not all the objects have an image. So this doesn't have no image, so the second condition cannot be fulfilled. So this relation is not a function. Now we have a set notation here where there are three order pairs, and we have the object as 1 and 0. The images are 3, 5, and 9. So we want to see what type of relation is it. So what you can do is, to make matter clearer, to make it clearer, if you use the arrow diagram, it will be 0 and 1, and the images are 3, 5, and 9. So we have order pair 0, 9. That's one relationship, and 1 has two images, 3 and 5. So from here we know this is 1 to many relation. 1 to many relation, and whether it is a function, we have to look at the condition. The first condition is it must be 1 to 1 relation, or many to one relation. And the second condition that it must fulfill is all object must have image. Must have image. So over here, the first one is this is one to many, so it doesn't fulfill this condition. But then all object does have an image, so it is an image. So however, it must fulfill the two conditions in order it to be classified as a function. So in this case, this is not a function. Now let's find out what type of relation it is. If we put it in arrow diagram, we'll get A, B, C as the object, and 1, 2 as the image, where A map into 2, and B map to 1, and C map to 2. So from here we can see that this is many to 1 relation. Now whether it is a function, let's see whether it fulfills the two conditions. The first condition is the relation must be 1 to 1, or 1 or many to 1. And the second condition it must fulfill is all object as an image. So it is many to 1, so the first condition is fulfilled, and you can see that all the object here has an image. So if you fulfill both the condition, so this relation is a function. Dear student, the graph here show the relationship between the set x and set y, where it is given the domain for x is between -1 and 12. That means the domain is -1 here to 12. This is the domain, yeah. And all the possible images for this domain fall within the lowest point. This is 3, and the highest point of the image, which is 10. So this is the range for the given domain. So the range is between 3 and 10, inclusive 3 and inclusive of 10. Now let's see what type of relationship is that between x and y. So from the graph you can see that there are more than one object that have the same image, right? So we can conclude here that the relationship is many to 1, and it is considered a function as it fulfills the two conditions. The first condition being this is many to 1, and the second condition is that all the object in the domain, yeah, has an image in the range.